Welcome back to the second video of this Kubernetes series that we are covering right now. So in the last one, or in the last video, we talked about how to install Kubernetes on local environment as an alternate to Minikube. And as the agenda of this series again is to cover the entire Kubernetes framework, in this session we'll talk about the most basic skill set required for Kubernetes. You can also consider it as a Docker session individually. So the heart of Kubernetes series is container. So what exactly is a container? So basically you can consider it as a bucket within which you can put all of your application code along with your dependencies. So for example, let's say you have your code base somewhere in Git, and then from there you have a pipeline which basically creates your application artifacts and pushes it to any kind of code artifactory. So you are going to take that code zip or that code module or that deployable from there, and you are going to put it within the container, and you are going to run the container as a whole. So why do containers has been so much accepted globally as a large scale deployment method? So if you remember, in legacy environment, these applications were directly hosted on top of the physical servers. So that was more of like, let's say you have one server which is having like 8 CPUs, you have 16 gigs of RAM, and then you're hosting 8 applications on top of it. So what you had to do? So you had to like segregate these applications so that they can have, each of them can have like 1 CPU and 2 GB of RAM individually. So that resulted in like shared space and resource utilization between different applications, because basically we are hosting these 8 applications on top of a single server, and that again raises one administration issues. So by that I mean, let's say you have these 8 applications and they are being managed by different application teams. Now you have to provide access, at least for dev environment, for developers to access these servers. Definitely you can have these users in different user accounts, you can have these instances created in segregated way, but again there are some administration headaches that you really need to take care of. And each time when you configure a new application, you have to have the configuration effort counted for every time. So to overcome this, we have containers now. So what exactly is the added advantage that we have once we adopted containers? So you have segregated environments for each and every application environments. You can have multiple versions of the same application without that much of effort to put in. You have a consistent environment because we know like these containers, what we can say, it's running on some kind of container framework, and you just pick this container from here, you deploy it on top of another infrastructure which is also having the same container runtime, and it will run consistently. Now similarly you can have the same code running everywhere, and if you want to migrate, it's more simple. You take the container out of this host where you are hosting it, and you just host it on top of other container frameworks host. But if you think about it, we can have the same thing, or we can have the same feasibility with virtual machines. So what exactly is the advantage of containers? So there will be some agree and disagree on this point, but again I'm going to speak from the containers perspective. So what exactly is a virtual machine? So if you remember last time, the POC environment that I created, what I did, I do have a local PC on which I have a Windows 10 operating system. On top of that, I'm installing VirtualBox, which is kind of like my hypervisor layer, kind of like it provides your virtual environment on top of the operating system. And on top of that, I installed Ubuntu. So Ubuntu is kind of like the guest operating system that is hosted on top of my actual or host operating system. But if you remember, I downloaded that image from the Ubuntu website. So think of it, each virtual machine is like having their own operating system. But in case of containers, we do not have to download that entire operating system, but it's going to basically inherit the host operating system properties. So it's a lightweight environment, as well as it's small in size. You are not installing the entire OS, just you are taking a part of it, you are putting your code on top of that, you are creating your own container, and you are hosting your applications. Now, virtual machines basically isolate these application servers, because let's say you have virtual machines now, and on top of each virtual machines you are hosting your applications there. So basically they are isolating your application servers. And when we talk about containers, think of each container as a separate application. So basically they are isolating your applications, not application servers. So both of these VMs and containers host isolated applications. But virtual machines, it's much more in size, because it has the entire operating system size plus your application size. But in case of containers, you are just consuming that application artifact size, the zip file or the WAR file or the deployable that we talked about. Now, the basic difference between these two is virtual machine isolation is done via virtualization techniques like Hyper-V. So Hyper-V is kind of like a Microsoft specific virtualization technique, but containers use OS level virtualization using namespace and C groups. So if you're familiar with Linux, you should be familiar with control groups, and it results in less overhead. To have a pictorial representation, what exactly happens in real life is, in case of scenario 1, that's a virtual machine. So in middle you see that we do have this host OS. So for me it's Windows 10, and on top of that we have the Hyper-V or hypervisor, and on top of that we are creating virtual machines. Now, virtual machine here is the guest OS that we create, because we download that image, again we configure it like a new host that we are provisioning within that part, and then we are hosting these applications on top of that. On the scenario 2, you really do not need any kind of hypervisor or Hyper-V. So what you do is you host this, or you install this container runtime on top of your host operating system, which is Windows 10 for me, and on top of that you create different container applications, and these applications are also like isolated from each other, so they do not coexist at the same place, as well as they do not share the resources. Now if we compare scenario 1 and scenario 2, you can see in scenario 2 we do not need that extra overhead of having a virtual machines installed, or we do not need a guest OS there to be an overhead, and we are just directly skipping that. And the third scenario, or I would say the most common scenario, is having the container runtime installed within your virtual machine. So I'll detail maybe in a later video where we are detailing about Kubernetes, because when we host Kubernetes we are doing the scenario 3. So even if you host your Kubernetes framework on top of any cloud environment, they are going to provide you the virtual machines, because in any kind of CSP like cloud service provider, when they provide a virtual machine, they do not basically give you access to the physical server, but instead they will give you access to the virtual machine. So all of your kubeadm, kubelet, all these things are installed on top of a virtual machine. So when we talk about a multi-node cluster in a cloud environment, it's basically a pool of virtual machines having your master and worker nodes together. So it's kind of like a hybrid one. So when we have, let's consider VM2 in scenario 3. So within that we have this guest OS, we have the container runtime installed on top of that, and then on top of that we are having, or we are hosting, the container specific applications. So what exactly is Docker? So Docker is an open platform for developing, shipping and running applications using containerization technology. So people say Docker is container. No, it's not true. So containerization is a technology, and Docker is a enterprise company, and they are providing a container, or how I can say, it's like a containerization technique which you can adapt, and on top of which you can host your applications, and you can host it on top of any Kubernetes framework, or maybe in Docker itself. So it's a most popular container framework that is currently available in market, and there are other alternatives too. So there is Hyper-V, there is Rocket, which is by CoreOS. Now, as you know, in the latest version of Kubernetes, they said like, okay, they are not going to support any updated version of Docker. So you can have CoreOS RKT as an alternate to Docker. So similarly, there are a lot of others alternatives to containerization techniques, and being the most popular one, we are going to discuss about Docker today. So how exactly this entire thing works? We know about Docker, we have heard about it, we know that we can host our applications on top of this Docker framework, but how actually that happens? So think of it like this. There is, when you install an operating system, what do? You reach out for a CD, or maybe you download that ISO image from that website, right? So similarly, you do have this Docker hub where you can, it's kind of like a Docker marketplace where you can list all these available images, for example CentOS, Ubuntu, Debian, Alpine, Nginx, and a lot of those. So those, consider those as base images. So by default, you cannot create a base image. You have to inherit one base image, and that has to come from Docker hub, or it has to come from other sources. So let's consider this. You're taking the basic or base image from Docker hub and you are storing it in your own local image repository when you have the Docker daemon installed in your local system. So the first step would be to pull those image from Docker hub and get it within your local image repository. Then let's say I want to host an application. Maybe I want to host an application in Python. So what I'm going to do, I'm going to have that image pulled in first in my local system. Then I'm going to install Python on that. Let's say I pull Debian, or let's say I pull Ubuntu, and on top of that container or base image I install my Python. Then I do all this module installation. Let's say I want to have like Boto 3. That's an example of AWS SDK for Python. So I want to install this Boto 3 module. So I'm going to do pip install Boto 3 on top of that container. Then if I have a code that is having all my entire functionality of my applications, I'm going to place it within that container, and then I'm going to create a new image out of it. So similarly, if you follow this image, you can see that in first stage we are pulling one image to the local image repository, and then we are creating a Docker file. So Docker file is kind of like a conventional file name from Docker Enterprise, and you have to create this file, and we are going to write the different steps. What exactly do we need to execute within that container which we downloaded in order to make the final application specific image. So there are simple steps within Dockerfile which we are going to come to at a later point of time, maybe after this stages part only. And let's go through the Dockerfile stages, what exactly we are going to do. So first, as I mentioned earlier, you have to have the base image available to start with. So we are inheriting the base image that we downloaded in our local repository. So first we do it, then we add the application server libraries, whatever we need. For example, I gave an example of Boto 3 for Python, right? Then once everything is there, I need to have my application code inside that Docker file. At least I need to mention that path where my application code is. So once we are done with that, we are confident enough that these are all the things that we need in the new image. Then we create a new image out of it using the Docker file, and then again we store it within our local image repository. And now from there, if you want to again store it in Docker Hub in some private repository or public repository, you can do that. Or maybe you have other solutions like QA or maybe JFrog artifact. You can also store that there. Now let's move on to the actual hands-on part, where we are going to download one image from Docker Hub. We are going to create one Docker file. We are going to install let's say Python. We are going to have the Python modules installed within that Docker file. We need to write how exactly we are going to import the application code there, and then we are going to create a new image. And once that is done, we are going to run that Docker image and we are going to see if all those things what we needed is present there or not. So moving on to this hands-on part of this tutorial, I have already created one virtual box that is hosting Ubuntu 20.04 like before, and we will just power it on at first. Let's see what's the IP this is holding right now. It's 155. Okay, now to install Docker at first, let's go to Google and we will say install Docker on Ubuntu. We'll go to the documentation. It says like if we have any old version of Docker, first let us uninstall that. There is a fresh VM I have, so there is no chance that we are having Docker there, so I'll just follow this tutorial. So just go here, sudo apt-get update. That's a good practice that we need to follow each time. And installation of the HTTPS transport layer. Then we need to add the JPG key from Docker. Since we have added new repositories, we need to refresh the package list once again. And finally, we're installing Docker. Meanwhile the installation completes, let me give you a background of the use case that we are going to follow today. So I do have one Python application that's a simple web app right here. It's going to run and it's just going to give you a return of hello world. So if you hit that URL using that IP address and port, it will just tell hello world. So this application we are planning to deploy that on top of our container that we create right now. So again, as a standard, I will take Ubuntu, and on top of that I will install things. So meanwhile the installation has finished. Let me do, okay, I have to be root first, docker ps. So okay. Now it's not the official way of doing that. So if you remember, we talked about Dockerfile. Now in Dockerfile, what we do, we just write the steps that we need to execute within that container, so that the ultimate goal is to create a image out of it that will be application specific. So what we will do is we will just create one file here in my local system, and I will name that as Dockerfile. And I am also going to let's talk about a hierarchy. So when we talk about an application, it should maintain some hierarchy, right? So I will just mention like src source, where I will host my application code, and we are going to write this Dockerfile. Okay, now if you want to download the Ubuntu image, what we need to do? So we need to first check at Docker Hub, right? So Docker Hub, let's go to Docker Hub. Let's find an image for Ubuntu, explore here, let's search for Ubuntu. So if I click on Ubuntu here, it shows Docker pull Ubuntu. So it gives me the command that I can execute at my local system to pull that Ubuntu container, and this is going to be the base image that I was talking about earlier. And here we are going to the URL hub.docker.com, but in case if you do not want to go there, you can directly from command line do the same. So we need to do docker search Ubuntu, and you can see the same image has been provided here. So in order to download or pull that Docker container, what we have to do is docker pull Ubuntu. Now again, this is getting downloaded from Docker Hub. So if you remember, in the slide section we mentioned that we are going to pull it from Docker Hub, but it's going to store within our local image repository. And how we can check what are the images that we have right now? Just do docker images, and you can see currently Ubuntu is present. Now let's write the Docker file. So before we write the Docker file, let us log into the container first and execute the commands one by one that we are actually going to write in Dockerfile to make sure all these commands are valid and our application is getting deployed to. So we will do it side by side. Let's open it like this, and we will take this one here. Okay. We have the Ubuntu image present locally, so we will do docker run -it, then the image name that we have, then /bin/bash. Now one important thing here, by docker run we are saying we are trying to run a container using one image Ubuntu, and we are saying -it, that is we are going to have an interactive session, and at last we are seeing like there is a bin bash, that is the shebang. Why we are mentioning that? So what Docker is going to do is it's going to run Ubuntu in this console and it will execute bin bash within that. So if I press enter, I'll be getting the bash prompt of that Ubuntu container that we are having right now. So if you see, I was within the host name Docker Lab, which is the host of Docker engine, but now once we executed this command, we are within the container. So as a good practice, what we should do is we should always do a package refresh each time. So we will do apt get update here, and similarly we are going to build this file here. So as I mentioned, we need to have a base image, right? So that should be my from. So I am saying that docker file that I am creating, it should inherit from Ubuntu. Next, then any command that you want to execute within that container should be within run. What I did apt get update. So I'll just paste it the same thing here, and then this application that we have right now, that is hosted on top of Python, right? That sample app that we are showing. So it's just going to print hello world. So we need to make sure that Python is installed on this container machine. So we will see like whether Python is installed or not. Python command not found, Python 3 command not found. So we will just do run apt get install Python 3. Let's make sure this command that we have written, this is properly getting executed within that container, and yes, it is. Now this code base is basically written on the Flask framework within Python, so we have to make sure that the module Flask is installed there. So for that we need pip. So let's see whether pip is there or not. It's not there. So we will again install run apt get install Python 3 pip Python 3 dev. Yes, getting installed, so we are good. Now additional thing here, we can have a tag called maintainer. So here we can write a format like name of the maintainer, then within brackets we can say email of the maintainer. So let's say now let's talk about that application now. So we have all like the application server, which is Python installed, or the application environment installed. We have the modules installed. Now we have to think about how we can place our codes there. Now, as I mentioned before, like we have a Docker file, then in parallel to that we have src, where we have this application file or this Python file. Now here we are going to add a new file, and we will name it as requirements.py in parallel to Dockerfile, and we are just going to say Flask. So this is my dependency, and we are going to copy this file. Before that, let's specify what exactly within my container, what exactly is going to my work directory, where my application is going to get hosted, where actually my code will run. WORKDIR is /. Let's say it's getting hosted in /. Now let's copy these files there. So what we will do is we will just copy /requirements.py. Sorry, it should be txt. It's not a Python file, my bad. /requirements.txt. So what I'm trying to say here is I'm copying this requirement.txt from where I do stand right now, that is beside my Docker file. So I'm writing /, that means within the directory that we are currently in, and it's going to get copied within the container in /requirements.txt, and we need to have the module installed. So we will do apt pip3 install -r requirements.txt. So all my dependencies are met right now, and now we are going to copy the code base, which is within our src folder. So again, we will do copy everything from here, and we will put it, everything from here means dot, and we will put it within the root, as we have already specified the WORKDIR is root. And this application will by default run in port 5000, so we need to make sure that the port 5000 is exposed from the container itself. And at last we are going to execute cmd, and we are going to write python 3 src and sample app.py. That's it. We are out of this container right now, and make sure that we are putting -y, because every time otherwise it will ask you for yes or no, and your container creation will fail. Okay, so we are good here. Now what we need to do is, now this is my local system, so I need to make sure all these files that I have here is getting copied on this right hand side, that means within the virtual machine that we have created. So either you can do like copy files directly via SSH or SFTP, or you can just directly copy paste it. So since this is kind of like a very small setup that we have right now, I will just create a directory here manually. So mkdir test docker cd test docker vim docker file, done. So if I look at this directory right now, we have the Docker file which is needed to create that image. We have the requirements file which is required to have the dependencies installed, that is the Python module for Flask, and within src we have the application code. So let's build a Docker image. Docker build -t. Now you have to name that image that you want to do. So here it's hello world. I'll name it as this, and let's say it's v1, and within my current directory, that is within dot, the Docker file is present. So we'll just hit enter. Oh, sorry, it has to be lowercase every time. Now one important thing to notice here, you see that there are 11 steps as a total, and if I go back to my Docker file, so these are 11 lines that we have added. So this Docker build command treats each and every line as a separate step, and each time, if you notice from Ubuntu, so this is an image ID that it's getting generated, and each time when it executes a step, it basically removes this image ID, and after writing this change to the same image, it writes to a new image ID. So that's a important thing to notice, though it's not like you're going to face it in practical world, any challenge within that, but it's a good thing to notice here. Let it complete. We are in 8.11. pip installed requirements. Okay, Flask got installed, copied, and it says that successfully built this image and tagged that image as hello world v1. So now let me just do docker images, and I can see there is a image called hello1 with the tag v1 present in my local repository. Now what I need to do is I need to execute this container, and sorry, we need to execute this image. So we are going to just do docker run -i, or let's just do docker run hello world v1. Now if you remember, the app was exposing on port 5000, so we need to make sure that if we want to access it from this local machine, that is the test docker, we need to have a proper port to port mapping, because that application is getting hosted within that container itself, and it's exposing that 5000 port. But from my machine also, I need to make sure some port of my machine is also getting mapped to that application port. So for that, command is -p for port. I'll just use 5000 in my local machine and 5000 here, and it says running on 0000 5000. So if I click to open a new interface, and if I log into the same host machine again, if I do curl http localhost 5000, I should say hello world. Yeah, here it is, hello world. Now again, I am using the bridge adapter, so if I directly go there in this IP from my local browser also, I should be able to see that hello world. So my application, whatever you are hitting right now, that is getting reflected from here. So let me just execute it once again. So now there is no console output. Let me hit it once again. You see there is an entry like, and it's 200. So the HTTPS or HTTP request was successful with 200 return ID. Now once we have this, let me go through certain basic things of Docker. So we already know some of these commands, right? So we know docker images is to list what are the images that we have right now in our local system. Now, how exactly to track what are the Docker containers that is currently running in my system? So I will just do Docker PS. It will show you all the live containers that is running right now. But when we kill a container, or when we stop the activities within a container, if it is not doing anything continuously, Docker containers cannot be up like 100% times. So even if you see in our Docker file, that's why we said in CMD we said Python 3 src sample app.py. That means when this Docker container executes, the last execution point or the command will be to execute that application. Now once we do Control C, or once this process is completed, the container will also shut down. So as I already did Control C here, so it has shut down. So there is no currently running container within our local system. But if you want to see the history, what are the containers that were running earlier, so we just need to do Docker PS -a. Now here if we see in history, this hello world v1 was created 2 minutes ago, and it was killed about a minute ago. And each time when you create a container, if you do not specify a name, it will take some random funny names here. That's completely randomized. If you want to specify any name, you can directly just put an argument there to, I think it's with -n. You can directly put it there, and it will automatically, you can assign names there. But it really, I mean, no one cares about what exactly is the name of the containers. Everyone cares about the container ID, so that should be fine. Now let's say I want to delete this container from my system. So I'll just do Docker rm and container ID, and it returned the container ID. So let's see now whether this is still there or not, and it got removed. So similarly, a quick thing is, if you want to delete all these past containers which ran here, if you want to delete all those entries, we can just do some scripting in Unix shell, like awk, let's say grep -v container awk. We will just take the first field, all this container which was previously run got deleted. Now similarly, if you want to delete it, Docker image, just list the images, and the command is pretty much like same, but instead of Docker rm, we are just going to mention Docker rmi, that's remove image. So Docker rmi, let's take one, let's say Ubuntu. That's a base image that we took, but we do not need it right now because we already have a new one. Oh, you cannot delete that because it's basically got inherited there here. So let's remove the test one, and it got untagged and deleted. If you see, there is no test image right now. So again, I think this is fairly enough for the basic Docker to start with Kubernetes, and you can explore the different Dockerfile options that we have. So I have already listed some of them here, which I am going to post in the comment section. So similarly, if you have any suggestions for any kind of improvement that we need to make, please do let us know in comment, and I'll try to make sure that next time we are not repeating the same thing. And thanks very much for watching this video, and like every time, please do like, share and subscribe to this channel. Thanks for watching. Bye.